After all the videos that I made about, in a certain way, theory about how to get such a 16 kilohertz transformer into a working condition, now it's time for practice. And practice is, of course, always say more cumbersome compared to all the theoretic things. Anyway, I've talked about these high voltage diodes, talked about this circuit, etc., in an earlier video. And now finally I've made this schematic, and it shows, say, the first experiments that you can do trying to find out whether such a 16 kilohertz transformer can do its job. And the most simple thing is to connect to the secondary a small neon tube here and also here. And then, of course, such a transformer is in many cases in this way that you don't know where all the windings are. In such a transformer there are often all kinds of windings, backcoupling windings for, say, specific purposes, especially in the past when it was used with a tube oscillator, say kind of backcoupling winding, etc., and also, say, in the 1970s, these tube 16 kilohertz oscillators were used in sometimes very complicated oscillator circuits. Anyway, so for a hobbyist, or when you want to do experiments, it's of course always necessary to find out where the windings are that can give out the maximum output voltage. And there's a very simple way to do it. Like I told, connect a neon tube to the secondary here, the secondary here, and the secondary here. You can see it. This is the neon tube. It goes to the secondary of the high voltage transformer. And now we're gonna search which coil on the primary does have the best effect, so generating the highest voltage to the secondary coil, that is here. So it's all hands-on electronics, no theory any longer. Anyway, you can study here of all the, say, wires inside that primary coil. And well, there are of course some wires that give the best energy out on that coil when we add a voltage to them. So I do that with my voltage supply, and there's always in my voltage supply a protective resistor of 2 ohms. That is in fact an automotive lamp that does the job, say current protection. The current doesn't get too high. Anyway, the schematic again. Here is the schematic. So finding the primary coils of these 16 kilohertz transformers. Of course, the normal transformer theory is can be used here. The ratio of the windings, etc. But like I thought earlier, the resonance is, say, a strange, not a strange, but a certain phenomenon that can, say, peak up the voltage very high. But of course we are at the moment not in that situation. There's no oscillator connected here. That can have, say, a certain effect, say by turning up the voltage. Anyway, my camera is now fixed on a certain position. I will switch off all the lights, and now we are going to the reality. This transformer, and I will, say, give these electrodes here a certain voltage via my power supply and search where the coil is that gives the neon tube on the secondary its best voltage, and that is the coil that I am going to use to drive the oscillator on 16 kilohertz. So somewhere here there is a coil, and that will have the best property to be driven with the help of a transistor or a Darlington or whatever. Anyway, let's see and look. Switch off all the lights now, and at first I'm going to connect here my power supply, for instance here, to the first electrode of the coil. Let's see what happens. It's dark now, okay, no problem. Let's see. Well, this is, say, quite lucky, by the way. Quite lucky, I hope you can see it, that the neon tube here is acting fierce. So these, say, this part of the primary coil can be used to drive it to get a high voltage out. So I don't want to get further because this worked. So anyway, demonstrate it again. So here I touch with the crocodile clip, and at the same time you can see the neon tube light up. Well, of course it's dark, so it's also, say, quite a problematic. Well, here you can see it. Now I'm touching these electrodes of the primary coil, and you can see that the neon tube lights up quite fierce. So testing other electrodes of that primary coil, there shall be perhaps some other coils. Tipping now. I hope this video is not too sloppy, but tipping now all the coils. So this is, say, I think this is the right coil to be used as a driver coil. So now we go to this was the first coil here, neon tube, secondary, primary, etc, etc. Now I go to the second coil, and that's here. And I've also connected here a neon tube here to that coil. So let's again search for the best winding where such a coil can be driven out to its best properties. And of course that's always a kind of search. Try it now. Well, I'm lucky. This is the winding. So I'm going to show it now. This is the winding where the neon tube lights up. So this is the best way to find out the best winding to be driven with a Darlington transistor or whatever transistor. And well, I'm gonna go through all the other electrodes of this coil, 16 kilohertz coil. So no flashing of the neon tube. So there is a certain electrode here. Oh, well, this works. Anyway, say this is, by the way, you can see a spark here, also a good sign. That means that current is flowing. And again in the dark, you see that spark again, and here we see that neon tube lighting up when touching the primary of that 16 kilohertz ferrite coil. Gonna test some other electrodes, and you can move in a kind of coarse way over them. And this is what happens when you see it from a not too close distance. So here I'm touching the winding that has to be used to drive that high voltage oscillator. Thanks for watching. This is the practice. And the practice of electronics is always far away from the theory. That's my experience. Thanks for watching again. And I hope tomorrow I can give a really working circuit, or the day after tomorrow, a really working circuit on 16 kilohertz that can give out approximately 500 volts DC